The Reflex Plus 4130 from Technotest brings automotive diagnostics into the 21st century. Reflex gives you the convenience of a data graphing scan tool, multimeter, oscilloscope, gas analyzer, flight data recorder, and digital data resource all in one tool. Having all of these functions available leads to faster and more accurate repairs, saving your repair facility time and money. The Reflex Plus 4130 is a complete diagnostic package covering such systems as engine controls, anti-lock braking, airbags, body control computers, climate control, and more than 60 other vehicle systems. In addition, the Reflex is specifically manufactured to work with almost any motor product with onboard diagnostics, including European, Japanese, Korean, and American cars, light trucks, and even motorcycles. Made to exacting standards in Italy by Technotest, the Reflex is ready for the European market and the world. Let's look at some key features of the Reflex Plus 4130. When you begin your diagnostic procedure with the Reflex Plus 4130, one of the first things you'll notice is the clarity and brightness of the custom designed display screen. The quality of this screen is far superior to many other tools on the market today. Most technicians start by looking at diagnostic trouble codes. Of course, the Reflex Plus 4130 handles this with ease. Right away, you'll know you have stored codes by an audible beep and flashing light displayed by the Reflex. The Reflex has a huge and updatable onboard database of information about these DTCs. By quickly scrolling through the PID list, you'll see the information you need about the components to help you with your diagnostic procedure. You can output this information via wired or wireless connection directly to your computer using the Smart Module adapter. For further diagnostics of a particular system, you may like to use a wiring diagram or circuit schematic and a multimeter to test voltage. Once again, you're ready with the Reflex Plus 4130. Using the updatable EcuData card feature, simply select the vehicle and send the image to your printer via the Smart Module. Now you're able to take that printout to the vehicle and use it in addition to the multimeter feature built into the Reflex Plus 4130. The multimeter feature is easily accessed using the same main menu screen. But what about waveform patterns, such as for misfire analysis? Simply connect the oscilloscope module and you're now checking voltage or amperage waveforms with ease. And many repair facilities rely heavily on 4 and 5 gas analysis for diagnostics. With the optional gas module installed, the Reflex Plus 4130 is ready to perform this function too. The repair is now complete, but you're not finished. You need a test drive to verify the fix. Using the included Smart Module feature, you now have a self-contained flight data recorder. You pay attention to the traffic while the Smart Module records the data. Upon returning to the shop, the flight data recorder will now communicate with the 4130 to display the data. By now, you should realize the Technotest Reflex Plus 4130 is the one diagnostic tool the competitive 21st century automotive repair facility must have. Innovative, versatile, and cost-effective. There's no need to wait for the future of diagnostic tools. With the Reflex Plus 4130, the future is now.
Now we're going to go to live data in mode 1 to do some diagnostics on this. So the first thing we notice, we have a system running too rich. So the first thing you might want to look at is long-term fuel trim. To make this tool run a little bit faster, you might want to only pick one PID at a time. So the first thing I'm going to look at is the fuel trim on this particular vehicle. I'm going to short-term fuel trim, and I'm going to go to long-term fuel trim. And when you hit F2, after you push enter on it, you will get the screen. Now at this point you're going to see that we have long-term fuel trim at 15.6, which means this car is adding a lot of fuel to this vehicle. And our short-term fuel trim is about minus 3.8, so it's trying to balance. If I push enter, we now will have a graph on each one of these. Now the other thing we might want to do is bring the RPM up to about 2 grand and hold it there to see if they're working properly. This could be a lean idle condition, or it could be a condition that's throughout the RPM range. So the first thing I'm going to do is go ahead and rev the engine up and see what's going on. As you can see, I went up to about 2,600 RPM, and by listening to the engine, my long-term fuel trim still stayed at 15.6. So my long-term fuel trim basically is telling me that I'm adding fuel throughout the RPM range, which could be a sensor problem, an O2 sensor problem. So we need to do some further testing. But I noticed my short-term fuel trim did make a major change when I went at higher RPM. Now, I froze the screen by hitting the left arrow on the tool, and it froze the screen. If I hit enter right now, I'll go back to live data. And if you notice, the short-term fuel trim will start going to -3, and we're still locked at long-term. The next thing I might want to do is go back to F2, and I might want to look at what other things we think. We would look at our O2 sensor to see what it's doing. So I'm going to go up to short-term fuel trim, push enter again, turns it off. Long-term fuel, turn it off. I'm going to go down to my O2 sensor location, don't need that, but I do O2 sensor bank 1, sensor 1. I'm going to hit F2 again, and at that point, I get the O2 sensor sitting on the screen. Now, if I hit enter, it's going to graph. If I hit F3, it's going to make it larger. Looking at the O2 sensor, I can see we're staying on the rich side, so something is affecting the car, and we're staying a little bit on the rich side. You should see an O2 sensor switching under 200 millivolts and going above 800 millivolts on a regular basis. This O2 sensor doesn't. So we'd probably have to create a vacuum leak, apply propane to double check the O2 sensor. If it doesn't meet our specifications, we're going to go ahead and replace it. The O2 sensor at this point might be the problem with this particular vehicle that we need to take care of first. We've already tested the O2 sensor, the short-term, long-term fuel trim, and that leads us to the fact that we probably have a bad mass airflow sensor. Now, on OEM data is a little bit faster in its response rate, so I have chosen the OEM data and went into a data block. Now, the data block I have has engine speed, engine load, injection time, and intake air quantity. Well, intake air quantity is still our mass airflow sensor, and it's in grams per second. Now, I selected this and put it in blue. If I push the enter button, it graphs it out and fills the screen. So the first thing I'm going to do is go ahead and start this engine. Okay, at idle I have 760 RPM. I have an engine load about 33%, 34%. My injection time is 3.96, a little on the higher side. If I look at my intake air quantity, I got 4.1 grams per second. Now the next thing we need to do at this point is snap the throttle and see the response on the different PIDs that we've got up here. Injection time should increase, mass airflow sensor should increase also. So I'm going to go ahead and snap the throttle. As you can see, I only got about 59.2 grams per second, a wide open throttle in this vehicle. I'd like to see closer to 100 grams per second or over 100 grams per second for a good mass airflow sensor response. So it tells me that I have something affecting my mass airflow sensor. I either need to clean it and retest or replace my mass airflow sensor to fix this problem.